In this problem, we're asked to find all of the angles between 0 and 360 degrees that satisfy this equation. So as this equation is right now, it's not solvable. We haven't gone over any techniques that would allow us to solve for theta since we have two different trig functions. And so we know that we're going to have to rewrite the left side. But before we do that, I'm going to go ahead and look at the graph where this orange sinusoid is the result of 5 cosine plus 6 sine. So when I add the two together, I end up getting just another sinusoid. And so we call this a linear combination. I'm looking for where this will equal 3 in the domain 0 to 360. So I can see that I'm going to have two different answers. My first one is going to be, it looks like around 130 degrees, and then my second one will be somewhere after 330 degrees. So to rewrite this left side into a single sinusoid, we did this in previous videos, but we're going to rewrite it as a transformation of cosine, where I need to find the phase displacement and the amplitude. And once we have written it as a single sinusoid, that will then make this equation solvable through algebra. And so right away, I'm going to make a sketch using 5 as the x-coordinate and 6 as the y-coordinate. So since both sine and cosine have positive amplitudes, I'm going to draw this in the first quadrant. Again, x is 5, and our y value will be 6. So we can use Pythagorean theorem to find our hypotenuse, which will be our amplitude. And so we will end up with 36 plus 25, and we'll take the square root of that number, which will get the square root of 61. And since it's not a nice answer, I'm just going to go ahead and leave my amplitude as the square root of 61, just so we're not rounding too early on. Then to find our phase displacement, we're looking for this angle D right here. And so I'm going to go ahead and do the tangent inverse of 6 over 5. Since we're using theta, we need to be in degree mode. And we will do the tangent inverse of 6/5. And that will give me 50.194 degrees roughly. And that is the phase displacement. Remember, we think opposite, so since this was a positive angle, we subtract. So now that this is in terms of a single cosine function, that's going to make this equation solvable. So the first thing that I'm going to do is divide both sides by the square root of 61. So I will be left with the cosine of theta minus 50.194 degrees, and that will equal 3 over the square root of 61. Cosine is equal to a positive ratio, so that is going to put me into the first and in the fourth quadrants. And so to find my two unique answers, I'm going to take the cosine inverse of 3 over the square root of 61. So I know that the inside here, that theta minus 50.194, and we'll go ahead and use purple, theta minus 50.194 degrees will have to equal 67.411 degrees. And I know that if 67 degrees is an answer, that the negative of that will also be an answer. So I'm going to set the inside equal to the same angle, but negative. So then my last step for each of these would be to add 50.194 to both sides. So I would recommend using the entire answer in your calculator. So plus the 50.194. So I end up getting about 117.61 degrees. Same thing over here, but now I'm going to take the negative of that 67 degree angle and add the 50 degree angle to it. And I will end up getting negative 17.217 degrees. However, this answer is not in the domain, so I'm going to add one cycle, which is 360, to get an answer that is in our designated domain. So I will get 342.78 degrees. There's one of our answers, 117. Our second answer is 342. And again, we could look at our graph to verify that these answers are reasonable. And so we end up getting right here around 117. And then around here will be the 342. So since our answers are correct, we are done.